In this lesson, we try to understand visual representation of multiplication of two numbers as a rectangle. The visual of a multiplication of two numbers would be a rectangle with the length of the rectangle representing one number and the width representing the other number in the multiplication. This also is a visual illustration of the commutative property of multiplication. That is to say, the order of multiplying the two numbers doesn't matter. For example, 4 times 5 is exactly same as 5 times 4. And to see that through the visual, we don't need to know either 4 times 5 or 5 times 4. Let's see how. This is the basic unit square, or we may call it the little square or unit object square. This just represents 1. And 5 of such little squares can be joined so that their outline becomes a perfect rectangle with length 5 times as much as the unit square, while its width remains the same as the unit square. We know this is a visual for 5. We also call it a row rectangle. And here we see the first row rectangle, the second one, the third one, and the fourth one. Altogether 4 row rectangles, each of 5. And hence it should contain, or it should be a visual for 4 times 5. When we join all these row rectangles together without any space, then we can make a big rectangle like this. It has a length which is 5 times as much as the little square or unit square, and a width that is 4 times that of the unit square. So we see this rectangle of length 5 units and width 4 units represents 4 times 5. Now again, there's another way to look at the same rectangle, same big rectangle that represents 4 5s or 4 times 5. Look at this. This can be called a column rectangle containing 4 little squares. So each column rectangle is a visual for 4. And how many such column rectangles can we see here? The first one, the second one, the third one, the fourth one, and finally the fifth one. So we see 5 column rectangles, each representing a 4. Therefore, this whole thing, the whole big rectangle, should represent 5 times 4. No matter which way we look at it, one thing is sure: the total number of little squares that are there in this big rectangle must remain the same, or they remain the same. And hence, this total number of little rectangles viewed as either 4 times 5 or 5 times 4, they must be equal. That is to say, 4 times 5 is equal to 5 times 4. It clearly shows that the order of multiplying the two numbers 4 and 5 doesn't really matter. 4 times 5, 4 is first and then 5 is taken next. In 5 times 4, 5 is taken first and 4 is taken later. So whether you add 4 of 5s or 5 of 4s, the result must be the same. The beauty is that we don't actually need to know how much is 4 times 5 or how much is 5 times 4. Of course we know they both are 20, but the fact is, just take any two numbers, multiply them in one order or the other order, the result must be the same. We may not be able to know it, but the multiplication remains the same irrespective of the order, and this is called commutative property of multiplication. Even though we have used natural numbers, you will see that this logic basically works for multiplication of any two numbers, and you can see that multiplication of any two numbers is always commutative. That is, the order doesn't matter.